All right, Good Friday. So we'll go real fast. It's 2 sections in one. First thing we're going to cover today is, the first thing I'm going to talk about today is what you're going to need in order to cover the parallel and perpendicular lines. We're talking parallel and perpendicular lines. But first, I'm going to introduce to you this thing called point-slope form. Are y'all familiar with point-slope form? Yes?
Yes.
What's point-slope form if you know it then?
I know.
It's like whenever all they're gonna do is they'll give you a point and they're gonna give you a slope. All right. So it's when they give you a point on the line, and then they're gonna only give you a slope, like 3/4 or something. All right. What you got to do is put that in an equation called point-slope form, which is just this. Y, yeah, I heard you. Y minus y1 equals the slope times x minus x1. That's what you're going to need today. This here. So somewhere on that paper, you might want to jot it down. What that is telling you is they're going to give us a point. This is a line that covers the point 3, 2, that has a slope of 3/4. So, yes? All right, so with the point-slope form, this is going to make it extremely easy for you to go ahead and plot parallel and perpendicular lines once I get over there first. You would label your points as x1 and y1. So all you would do to put this in to satisfy this is this becomes y minus your y1 is what? 2 equals my slope is what? 3/4. Parentheses x minus my x1 clearly is, my x1 is 3. Now, you're not done. That's just the beginning of the point-slope form. You're going to need this to complete the parallel and perpendicular. All right? I'm going to get to it in a second. I just wanted to introduce this first. So when you have it in this form, you have to go ahead and distribute. This is now going to become y minus 2 equals 3/4x, and then 3/4 times -3, let's call that -9/4. If you almost look at this, it's almost getting close to that form that Deja was just talking about. We're getting close to slope-intercept form. From here, you will go ahead and add 2 on both sides. The 2's will cancel. You have y equals 3/4x, and we have to do 209/4. You can turn that into 9/4. No, it wouldn't be 4/4. 4/4 is 8. You would turn it into 8/4. Pause. Do y'all see how I just turned the number 2 into 8/4 so I can add the fraction? All right, everybody understands that? So this becomes -1/4. Now, Deja, what form is that we're in now? Okay, very good. So what you're gonna have to do is you're gonna have to remember this form of point-slope. You're gonna see I'm gonna come back to it. You'll have it in point-slope form. It converts down to slope-intercept form, where you now have your slope and your y-intercept. Now watch, you'll see how that's going to come to play when we talk parallel and perpendicular. Let me know when I can skip past this. Let me know when y'all jot that and I can skip past it. I'm showing you the preliminaries. You're going to need this to complete the first question. Watch, you'll see in a second. All good? Everybody understand this part that you need? Moving forward. Now what we're dealing with is we're now going to have a set there's going to be some lines that are parallel. So for instance, that's terrible. Let's say we have a line here. We'll call this line B. And they'll say line B equals y equals 3 over 4 x, and let's say plus 2 or something. They'll say line B, the equation for line B would be y over 3 over 4 x plus 2. What they're going to now tell you is to go ahead and create an additional line that's parallel to this line. And we'll have to create an equation. We're going to have to create an additional line that's going to be parallel to it. Oh, I misspelled parallel. Now, the notes that you need to understand, you should be jotting this down. Ladies, y'all doing a lot of chatter. That's crazy. But the parallel lines that you need to know have same slope. So the equation that we create, we'll call this line D. The equation that we create eventually for line D is going to have the same slope as line C, as line B. Does everybody understand that? All right. Let's say this crossed at the y-intercept. Let's say this was. We'll call this 1. We'll call this 2. So now that it's going to change this to plus 1, and let's call this. Freestyling it, -1, -2, let's call this negative. Alright, now, if you can see the top equation, B has crossed the y-intercept at line 1. If you were to try to create an equation for line D, it's got to have the same slope, so you can have something like y equals, give me the same slope, 3/4 x, but where does this one cross the y-intercept at? -3. Do y'all see how these two are now parallel? This, because they share the same slope. It's just that this line crossed that 1 and this line crossed that -3. They gotta have the same slope, so they're parallel.
So you just change it to make sense?
Just change the y intercept.
Pretty much, like I said, pretty much gonna change the y-intercept. Do you see that?
Just change it to
the
what
same
makes sense.
slope.
Is there like an equation you're supposed to do with that, or?
This is the equation. It's parallel. It's going perpendicular in a minute. Because you want to see what's going to happen. You're going to need, watch. So right now, you'll see. All right? Any questions on parallel before I move to perpendicular? All right, let me say that one. Now, you might have a set of lines. I'll do it this way. You might have a set of lines, and this one is just an example, that's going to cross each other to make like a lowercase t is what I call it. All right. Now, taking a look at this one, line L, or we'll call this line B, and we'll call this line D. Now, if you look here, line B and line D are what we call perpendicular. Now, it's the same thing with the slope-intercept form. It's just that, let's say, I'm going to write this one out. The slopes for perpendicular lines, pardon if I misspell it, all it is the slope is the negative reciprocal. That's all it is. So the slope is the negative reciprocal. Alright, the slope is the negative reciprocal. So for instance, let's say, not in this case, because clearly the slope is 0 for B. I'm just going to use an example. Let's say you had a line B, and the slope for line B was, no, let's use that 3 over 4, right? Just in case. That means the negative reciprocal. For you to get the slope of line D, you're taking line B's slope, taking the reciprocal and making it the negative value. So the slope for line D would be negative 4 over 3. Does that make sense? Perpendicular, same slope. Parallel is same slope, perpendicular, negative reciprocals of each other. Got that?
Yeah.
All right. Now, let's go to this sheet. Let's try a few. You're about to see what I mean. Aha. Yeah. Okay. On your paper, should look like this. Here we go. Let's do this together. Now, you can see what form Deja is number 1 in. Now, they're telling you that you got to write an additional line, ladies, over there. Hello. Hi. Hi. Just showing y'all how to do it. I don't know what y'all talking about over there. You got to make a line that's parallel, but it's got to go through the point 3, 0. Right? What do we know about the slopes of parallel lines? They what?
Oh, yeah, they're the same.
Slopes are the same. So we know our slope in this one going to be 2, 3, right? But we got to make it go through the point of 3, 0. What did I just previously show y'all? What was the first thing we went over?
The equation.
Of what?
Point slope form.
Dang. Put it in point slope form. You're going to need it. So you'll have, this will be your x1 and this will be your y1, because you got to create an equation that's similar to this. So now this just becomes y minus what?
0.
0 equals, what's my slope?
2 over 3.
Because we know the slope's got to be parallel, 2 over 3. This is going to change if it's perpendicular. Equals x minus
3.
Very good. If you look here, we're getting very close. As you can see the similarities. So go ahead and just distribute.
Wait, do we put the 1 after the parentheses, or they just leave it?
Where do you get a 1?
The 1 where that's minus.
No, this is for this.
Oh, okay.
Your 1 in this case is your y-intercept. This is where this line crosses the y-axis. Oh, the y, yeah, at 1. Remember when we went back to that other one? That other one we were doing, and we said
With the parallel?
that line crossed that 1, and this one crossed that -3. You see how both their slopes is the same? This one crossed that 1, and this one crossed that -3. You about to get the same thing that's about to happen here. So,
I got it.
what? All right, we're back. All right, so go ahead and distribute it out. You should get y minus 0 equals 2 over 3 x minus 2. No, it ain't. Right? And then in this case, y minus 0 just makes 0, or just y, equals 2/3 x minus 2. So when you explain this, you see that both of these lines are parallel. It's just this line crossed at 1 and this line crossed at -2. So right now, but get the game, because you know when I show you the next one, it ain't going to be points. It's going to be just 2 lines on the graph.
I don't get it.
And you're gonna have to wait it out. Don't worry, I'm going to work with y'all. We're going to do that like Monday next week.
I know.
Hmm?
The two, I don't understand.
Okay, so remember we distribute here, you get 2/3 x.
Yes.
And then we distribute here. So really this becomes 2/3, right, times 3. How do you write 3 as a fraction?
Yes.
3 over 1. So when you multiply, 2 times 3 is 6. 3 times 1 is 3. What's 6 divided by 3? That's how you get that 2. Slide? Can I slide in number 2? No? All right. Y'all got that? Any questions? I was talking to Noah. She wanted to decide.
Mr. Winter, I don't understand it. What happens to the 1 in the equation, like the +1?
The +1?
Yeah.
Remember, this is where this crossed the y-axis. This is where this equation crossed the y-axis. This is your y-intercept right here. So this line crossed that 1. This line that we just solved for crossed that -2. They both got the same slope. Remember, look. Like I was just showing David. When we had this, remember the yellow line crossed that 1, but the one we solved for crossed that -3. So you see how both the slopes the same. It's just this y-intercept is 1, and this y-intercept is -3. You'll see it in 2. Hold on, we're doing 2 right now, Nate.
But like, at the end, do I leave it like this? Real quick? Or do I leave that +4? Because I gotta add that +4.
No, you don't. No, you don't. Watch, watch. Watch, watch. Number 2. All right, Andy. In 2, remember this line, we'll call this in the red. Right? Like on the graph, this line crossed here. We about to find a line that's on that same graph somewhere, but it's going to cross somewhere else on the y-axis. But it's going to be parallel. So watch. We got a point of x1 and y1, right? So what's the slope here? My slope is what? Yeah, you do. What's the slope here? What kind? Yeah, yeah. You see the slope, man? Remember in slope intercept? You don't remember slope intercept form? Oh, we're gonna have to review that. Remember in slope intercept form? We'll run it back. Don't worry, we're gonna revisit slope intercept form next week. This is your slope. This is your slope. And this is y-intercept. In every equation, it's going to come to this format. Y equals some type of fraction or number, x, plus wherever it crosses the y-axis. So all this number staying here before the x is telling you how the slope gets to the line gets on the slope. This number is always where it crosses the y-axis. This last number is this. So as you can see the yellow line, where did it cross the y-axis at? 1. It's got a slope of down 3 and over 4. Down 3 and over 4. That's what we're doing. The other one here crosses the y-axis at -3. That's why it's 3 over 4x minus 3. So as you'll see, both these numbers are going to be the same for parallel lines. It's just the last numbers are going to be different. So, back to your question. This line crosses the y-axis at 2. And it's got a slope of down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. That's how you form the line. We got to create a line that's similar to this, but it's got to have the same slope, but it's going to be somewhere else on the y-axis. So we take this and put it in point slope form. This is x1 and y1. So this becomes x minus 4 equals, what's the slope?
Negative 1 over 2.
Negative 1 over 2. X my sorry, this was wrong. Point slope is y minus y1, which is 1, equals slope negative 1/2 x minus, what's x1?
X1 negative
4.
4.
So now, this is point slope form. When they just give us the point and the slope. We're going to turn it into slope intercept form now. By distributing the negative 1/2. So now this becomes y minus 1 equals negative 1/2 x. Negative half and 4, positive 2. You see how I got that with negative 1/2 and negative 4?
Yeah, negative, positive.
Positive, half of 4 is 2. Then what you gonna do with this 1? Bring it over. The 1's cancel. This now becomes y equals negative 1/2 x plus 3. That's your answer.
Okay.
You see now, they both have the same slope, but where does this line cross at?
It crosses at positive 3.
At 3. So this line is somewhere like this. And it's parallel. Like Adidas almost. Adidas stripes. So we just need one more stripe. So that one crossed at 2, this one crossed at 3. We'll stick with the parallels and before we move on to perpendicular. I'm going to stretch this one out, pause. Can I slide to 3? The best way to do it is, the best way you're going to get it is just for us to keep trying them. Fernando, how we looking? Good?
Good. I did most of them besides.
You got it? You understand it?
Yeah.
All right.
So if they're both or
Mhm.
negative, you just leave
Don't
them.
be mad to the front positive.
Okay. Let me try the number 3.
Why is the negative 1 up there? Why does it not change?
Where, negative 1 where?
The negative 1 over 2. Why does it not change from the positive 1 over 2?
Because parallel what? Parallel lines got the same slope.
Yeah, so you just keep it the same no matter
Yeah. When we get the perpendicular, I'm gonna switch. Just we'll focus on parallel first. Then we'll move to perpendicular. The whole front side, that whole front side is all parallel, right?
Yep.
All right, let's do that one. We'll just focus on that today. All right, how about this? I'm gonna show y'all 3 and 4, and then for homework, y'all got the rest of the sheet.
Okay, go Friday.
Can I slide?
No.
Okay. All right. Hey. Oh, Jesus. I see it. I see it. And I know it. Y'all getting this? You already understand it? Oh, excuse me. Excuse me. And I don't got no homework tonight. This the notes. It's just the notes.
And I'm trying to make sure I actually did number 3
I'm
right.
about to do 3 right now. Just waiting for everybody. So check it. Anoya, can I move on now? Oh, okay. Thank you. All right, Andy. And Miami. And Mayer. I got the initial line has a slope of -2 and crosses the y-axis at -4. We got to do another line that has to be parallel to this line, but it's got to pass through the point -1 and 1. Label them up, throw it in point slope form. Y plus 1. Let me pause and show why y'all. Did everybody understand why I said y plus 1? Double negatives, yes. Double negatives turning positive. Equal, what's the slope? -2. x minus or x plus 1. Everybody understand that? Double the negatives, turn them positive. Y'all got that?
Yes.
Then we got to distribute. So this now becomes y plus 1 equals negative 2x minus 2. You then go ahead and subtract 1 from both sides. One's canceled, giving me y equals negative 2x minus 3. And your answer there's your answer for number 3. Similar slope, one passes, one crosses at negative 4, the other crosses at negative 3. We'll trade grade that when we bring it back, and then we're going to slide over the perpendiculars. Here, you should have had x1, y1. Don't forget your slope is negative 2. It should have been y plus 5 equals negative 2 x plus 4, which becomes y plus 5 equals negative 2x minus 8, which will subtract 5 from both sides. We're going to make this y equals negative 2x minus 13. Any questions on number 4? Got that for 4? Solid. Y'all got the rest for homework. Turn back to this video and help you out with numbers 5, 6, 7, 8. Go Browns.